focus, pause. Chapter 2 deals with quadratic functions, okay? So everyone have heard of quadratic before, and the reason I say that is because you have heard of something called the quadratic formula, right?
Mm-hmm.
So you should be able to look at an equation and identify when it's quadratic, okay? Like you're familiar with linear, right? Everyone know what a linear function is, right?
Yes.
Linear. So linear is generally written in the form f of x equal mx plus b. Or you guys usually write y equal mx plus b, right? So if I ask you the question, how can you tell when a function is linear, right? How can you tell? The question is, how can you tell when a function is linear? So all of this was in my notes that I posted when a function is linear. So I hope you guys are keeping up with the notes. If you don't look at the notes or don't read the notes, then we're gonna move at a slower rate, and then you guys will be more behind schedule than what we are. So anyone wants to take a shot of this? How can you tell when the function is linear?
There's one x value for every y value.
That tells me it's a function, yes. So that is partially right, but that's for a function. So there's two ways you can tell quickly if a function is linear, right? One way,
It's a straight
obviously,
line.
well, that's from a graph, yes. So if you have the graph, you can tell it's linear by a straight line. So let's put three ways, right? If you have the graph, and it is a straight line, right? Then it's linear, okay? Alternatively, you can tell one of the answers right written in blue here. If the equation
Is equals to y equals mx plus b.
is y equal mx plus b, okay? And then secondly, which is, in my opinion, the easiest way, guys, the easiest way is if the power slash exponent
is 1.
of the variable is 1. That's it. Okay? So, for example, right, if we have 2x plus 3y equals 12, and ask, is this linear? Is this linear? You should be able to look at this and say, hey, that's linear. No questions asked. Okay? So there are two ways. Option 1 and then option 2. Because in this case, you're not given a graph, right? Option 1, 2x plus 3y equals 12, right? What is the power of the x variable here? There's a 1, isn't it? What the power of the y variable? 1. So we can say, since the powers is 1, this is linear. Okay? Option 2, solve for y. And if we solve for y, we're going to have 3y. 3y is equal to minus 2x plus 12. So y is equal to minus 2 over 3x plus 4. Now, this is your mx plus b, isn't it? So this is linear, okay? This is linear. So by looking at equations, you can tell whether they're linear or not. Well, we're not talking about linear today, but you should be able to tell we're talking about quadratics. So for quadratic, you must be able to look at it also and tell if it's linear, if it's a quadratic, okay? So quadratics can be written in the form f of x equal ax squared plus bx plus c. And that's how you guys used to talk about the quadratic formula, okay? So this is a quadratic function. Now, one thing to note about this when quadratic, something that's very important, a cannot, right, this coefficient here, a, cannot be 0. Because if a is 0, then you're just left with f of x. So maybe I should write, if a is 0, you will see what's happening, right? So note, if a is 0, then it is linear. Because you're going to left with f of x equal bx plus c, right? Where this is your m and this is your y-intercept. So b can be 0, b can be 0, b can be 0, c can be 0, but a can never be 0, never. Questions?
So if A is 0, it's linear, right? Straight up?
Yes, straight up. It's not quadratic anymore because you don't have a square term. So how can you identify when it's quadratic? When the highest power of the function is 2 and only 2, right? When the highest power is 2 and only 2, it is quadratic. Then it is quadratic. Okay? So quadratic can be written in 2 ways. They have standard form and general form. Just like linear, right? Slope intercept and standard form. So the standard form is something that I have a video posted that you guys, I hope you guys are following up the video because we'll never finish chapter 2. Standard form is f of x equals a parentheses x minus h squared plus k. And general form is h of x equals ax squared plus bx plus c. Okay? So most of you are familiar with general form rather than standard form. And you should be able to go back here. You should be able to take standard to general or general to standard. This will be on your next exam. You have to know how to do this. And I have a video showing how to do this online on Blackboard. Now, and I'm going to show you an example, so don't freak out today. Quadratics happen to be a family of polynomials, right? Quadratic and linear are family of polynomials. Okay? Now, why do I say that? Because a polynomial, okay, a polynomial is written as f of x is equal to an x to the n plus an minus 1 x to the n minus 1 plus a whole bunch of other terms plus a2x2 plus a1x plus a0. So that looks probably very confusing to you. Each one of these here are called a term in the polynomial, right? So a polynomial could have many terms. It could have one term. You guys have heard of a monomial and a binomial and a trinomial in prior classes, okay? So what is it really saying here? What you should know, or the point you should know, an minus 1, a2, a1, a0, these are coefficient. These are all coefficients. Some number, right? These are all numbers, okay? N represents the exponent. So you will notice here, n, if n is equal to 5, what will be the value of n here? N minus 1, so that will be 4. Do you follow? Can you guys hear me? Class?
Yes.
Yeah.
Yes.
All right.
Yes.
Okay. So the point of a polynomial to note is that the powers, so a little hint here, hint, in a polynomial, the powers or the exponent decreases. Okay. So example, f of x equals 5x to the 7th plus 3x to the 6th plus or minus, it doesn't have to be all pluses, minus 2x squared plus 7. This is an example of a polynomial. You can have missing power. Notice I went from 7 power to 6 power, right? And then it jumped to 2 power. So I'm missing the power 5, I'm missing the power 4, I'm missing the power 3, and so on. And it's okay to write because it doesn't make sense. It would not make sense to write this as 5x to the 7 plus 3x to the 6 plus 0x to the 5th plus 0x to the 4th plus 0x to the 3rd, right? It doesn't make sense to do that. So here, clearly you see 7, 6, 5, 4, 3, 2. Oh, I missed one. X, and then plus, let's say, 10, right? There is a power here also of a 1, an invisible 1.
Professor,
So, yes,
so it goes from the larger to the smallest.
correct. That's the
Okay.
correct way of writing it. I could have mixed it up, but generally when you write it, you have to write properly. So usually you write from highest or largest to smallest, okay?
Okay.
So these terms here in general, guys, later on you will see you'll have to, it all depends on what the question is asking. Like when we do long division, these are called placeholders, right? Remember back in grade school or in whatever grade, I don't even remember, is when you were adding, you usually put like a 0 in to hold the place values, right?
Yeah.
So when you do long division, these things here are called placeholder. You're going to need to put the 0 in for placeholders. But generally, when we're writing them here, we don't have to do that. Okay?
Okay.
So, a couple things about, so this is, let's look. So if I give you an example here, right? Example, g of x is equal to x squared plus 7x plus 12. Okay. And I ask you, is this a polynomial? Is it a polynomial, yes or no?
Yes,
Yes. Why do you say
Yes.
yes?
because it goes from 2 to like 1 and then the number regular.
So how about this one then? H of x is equal to 4x to the third plus 6x squared plus 2x plus 3 minus 2. Is this a polynomial?
No.
Is this a polynomial?
Yes.
So, yes or no? Someone said something I didn't hear.
I think so. No.
So the answer here is yes, this is a polynomial. Yes. And the answer here is no. So why is g of x a polynomial? Okay. G of x is a polynomial because the highest power is 2, okay? And there are no negative powers. The highest power in any polynomial must be 2. That's what a quadratic is, guys. Quadratic, okay? For any quadratic, okay? 2 and only 2 is the highest power, okay? So if you look at h of x now, okay? H of x is not a polynomial because the highest power is 3. That's it. No good.
So, Professor, when the power is 3, what's the name of that function then?
Actually, oh, sorry. Sorry. It is a polynomial. Messed up.
But it's like another name for that.
Yes, yeah. Hold up. It is a polynomial. Is a polynomial. Is a polynomial. Let me write this back.
Trinomial?
Is a polynomial, but not quadratic. Okay.
Okay.
Quadratic highest power must be 2. I'm sorry about that. The quadratic highest power has to be 2, right? That's what I highlighted up here. For quadratic,
Excuse me, sorry, you got cut off. Can you repeat that?
okay.
Thank you.
So the question that I asked was if it's a polynomial, not a quadratic, right?
Yeah.
If it's polynomial. So how do you identify when something is polynomial? You look at the powers.
You
If the
said that.
powers are positive, it is a polynomial, period. Polynomial cannot have negative powers. Cannot.
Okay.
Okay? Now, if I ask you, is it a quadratic, right? Quadratic is a family of a polynomial. So g of x is a polynomial, okay? Because there are no negative powers. And in addition, because the highest power is 2, it's a quadratic, okay? H of x is a polynomial because there are no negative power, okay? So h of x is a polynomial. Let me rewrite this. Is a polynomial because there are no negative power, okay? But it is not quadratic. Do you see the difference?
Yes.
Okay. Now, a couple of things you can tell. So why do you want to know 2 different forms for quadratic, right? Why do you want to know standard form and general form? Okay. So a couple of reasons why. Okay. Does anyone know what is the graph? What is the graph of a quadratic call? Okay. The graph of a quadratic. Anyone know what it's called?
Parabola.
Parabola. Yes,
Parabola.
very good.
Yeah.
Okay. Let me stop this for a minute. So the graph of quadratics are called parabola, and there are two types of parabola. There's this one here. Okay. And then there's this one here. That doesn't look like a parabola. It's not a V, okay? So this is called concave up parabola, and this one is called concave down. It's called concave up when these arrows are pointing up. Also, when the coefficient A is greater than 0. It's called concave down when these arrows are pointing down, okay? And this is the case when A is less than 0. Remember, A cannot be 0, right? If A is 0, as we said somewhere in the top here, okay, A cannot be 0, okay, because then we wouldn't have an x squared term. Okay. Now, this point here in the parabola, that turning point, okay, is what we call the vertex of the parabola. Notice when it's concave up, the vertex is a minimum point. And when it's concave down, the vertex is a maximum point. Okay, so for business application or business majors, you're going to see this where you don't talk about vertex in a business problem, you talk about the maximum or the minimum of your business.
Yeah.
Yeah. So if I give you g of x, so let's say given g of x is equal to 2 parentheses x plus 1 quantity squared minus 3. Okay, a couple of questions I can ask you. What form is g of x written in? Question. Question 2, is this graph concave up or concave down? And then 3, what is the vertex? So you should be able to answer 1 and 2 just by looking at this. So what form is this written in? So the answers here are as follows. The answers. 1, there's only 2 forms, right? Standard, there are 2 forms. What are they? Standard
In general form.
and general.
So it's written in standard form.
Well, let's go back and see, right?
General.
This is standard, guys. This is standard form.
What the standard?
And this is general form.
Yeah.
So is this standard? The example I'm giving, is it standard or general? Look at it carefully again. What form is this?
Standard.
Standard.
Standard form. You agree with that, Les?
Yes.
This is standard form, right?
Yeah.
So the answer here is standard. Now, when something is written in standard form, the vertex is very easy to identify. So we'll talk about that in a minute. Well, let's do number 2. 2. Concave. When we talk about concavity, we mean concave up or concave down. Okay, concave up or concave down. So what is the value of A in this example? What is A in this example, class?
Positive 2.
Positive or negative? That's all I want to know.
Positive.
Positive. And we said if A is positive, when A is positive, greater than 0 means it's positive, right? When A is positive, it will be concave up. Right? So it's concave up because A is greater than 0. That's the reason why. A is greater than 0. Yeah?
Okay.
Now, the third question you don't know, or at least we haven't talked about that yet. So the third question, the vertex. The vertex of this function, g of x, equals 2 parentheses x plus 1 quantity squared minus 3, h comma k is the vertex.
Yeah.
So the vertex will be
1, negative 3.
Minus
1 comma,
Negative.
right, negative 3. Why is that? Because in this standard form, where I wrote it, h comma k is the vertex. So when something is written in standard form, identifying the vertex is very easy. Please note it's not minus h, right? It's just h. Okay? Now, are you able to convert from this here, which we said is in standard form? Suppose I ask you, what is the general form, right? What is the general form of g of x equal 2 parentheses x plus 1 quantity square minus 3? We said this is standard form.
Yeah.
What is the general form? Can you tell me what the general form is?
Of that problem?
Yes. Or how do I go about getting it?
You have to multiply like 2x squared plus 2x plus 1 minus 3.
That's not, you have the idea, but you're saying what you're saying is wrong. Remember, this part is first. Exponents is first, right?
Yes.
So this means 2 parentheses x plus 1 times x plus 1 minus 3. You cannot distribute this 2 over here first. You can't do that. Okay? So this becomes 2 parentheses x squared plus 2x plus 1 minus 3. Right? If you FOIL this out, as you guys usually say.
Yes.
And then if you continue to simplify this, you get 2x squared plus 4x plus 2 minus 3. And finally, you get 2x squared plus 4x minus 1. This is the same as g of x, but this here is general form. So moving from standard to general, all you do is expand / multiply. Okay?
Okay.
When you go the other way, and this is what I have a video posted, you have to do what is called completing the square. Okay? So to go from general to standard, you must complete the square. And completing the square is a tedious, not difficult, but tedious. And you have to know it for this course and for calculus. So I am going to put it on the next exam. So please make sure you know it.
On how to change the standard form to general form, right?
Yes.
Okay.
So I'm going to do one example here. I'm going to do one example, and also I have a video because I know when I do one example, a lot of you are going to be, focused and wondering what I'm doing. I explain it in detail on the video on your notes. So let's say I give you write the quadratic in standard form. Okay. And I'm going to give you f of x is equal to x squared plus 6x plus 2. Okay. X squared plus 6x plus 2. So I am going to perform completing the square now. So this is equal to, remember in completing the square, this coefficient must be a 1. Okay, if it's not a 1, you have to factor out. Since it's a 1, it becomes x squared plus 6x. Actually, let me stay with different color. It is x squared plus 6x, okay? Plus, in a different color now, half of this number here, always, and you add it. 6 over 2, but you must also square it. Okay? Plus, now if I add something to an equation, in order to make it balance, I have to subtract it out. So I'm going to subtract from the 2, 6 over 2 quantity squared. Now 6 divided by 2, 6 divided by 2 is really 3, isn't it?
Yes.
So I can write this as x squared plus 6x plus 3 squared. And now if you factor this, you will get x squared plus 3, sorry, x plus 3 quantity squared plus 2 plus 3 squared is 9. So you have x plus 3 quantity squared plus 11. And here is f of x written in general form, standard form. Written in standard form.
Question.
Yes.
If we were to have a number in front of the x, what would we do then?
You will have to factor it out, and all of that is shown in that video. So for example, if there was a number here, you would have to factor out that number and put it out here first. So all of these here would now change.
Got it. Okay, thank you.
Now the big problem with that is when you subtract it out here, you see where I subtract this out?
Yeah.
Then what if you have a 4 out here, you'll have to put a 4 here also.
Okay.
Right? Really look at the video, guys, that I have online, and then if you have questions, just because the next time will be office hour before I see you guys in class again. So go to the office.
This week?
What's that?
Is the video in the folder that you put up like this week?
It's been there, yes.
Oh, okay.
So this is how you convert from standard to general.
Okay.
Yeah. And now we can tell what is the vertex. Suppose I ask you here, what is the vertex?
3 and 11?
No,
No.
close, very close.
Um,
Remember, standard form is written as x minus h squared plus k, right?
yeah.
So k is 11, yes. So it is 11 there, but what is h?
Oh, -3.
-3, right, -3,
Okay.
okay? H is -3. Questions?
No.
Okay. So, you know, let's do one because someone asked a question, right? I don't want to leave you guys hanging. Suppose I gave you write g of x in standard form and what is the vertex? So I'm going to give you guys 2 minutes to do this. So given g of x is equal to 2x squared plus 8x plus 7. I'm going to give you a few minutes to do it. Okay? Try it, and then I'll come back and we'll look at it and see what you guys have. Sounds good?
Yeah.
Okay, please try it. So if we're giving h of x equals 2x squared plus 8x plus 7, you're asked to find the vertex, then you don't have to go and write it in standard form. If you want to, it's fine. We can just find the vertex by using these two little formulas, as I call them. So in my h of x here, what is a, what is b, and what is c equal to?
So A would be 2,
A is 2, very good.
B is 8,
B is 8, excellent.
and then 7, C.
7, wonderful, right? Beautiful. So x is going to be minus b over 2 times a. So x is equal to minus, and instead of b, we're going to write 8 over 2 times a, which is 2. So x is equal to minus 8 minus 8 over 4, which is equal to -2. Do you agree with that?
Yes.
Now, what does this mean? Well, if we have an x value, you have just found the x value. And you know from basic algebra, how do you find the y value? Well, to find the y value, what is h of -2? You take the x and plug it into the function to get the y? And that is what this really means here. So this becomes 2 times -2 squared plus 8 times -2 plus 7, which is equal to 2 times, keep in mind this means -2 times -2, which becomes 4. And then if you distribute, this becomes 8. This becomes a -16 plus 7. Well, if you combine this, it becomes -8 plus 7, which is equal to -1. So this is your h and this is your k. So what's the vertex? -2 comma -1. Yeah, but Do you see a problem? Do you see a problem? When we did this problem earlier, we said the vertex is -2, -1, right? Here, the vertex is -2, -1. So, if you think that completing the square is long, that's the problem. It is long, right? If you think it's too long and you are only asked to find the vertex and not anything else, then you have an option to use this formula. You have the option to use this formula. Yeah? Questions? Any questions?
No.
Can you scroll down a little bit? Thank you.
Yeah. So, what is the goal right now? Okay, you may want to write this down. The goal right now is no matter which format I give you a quadratic, you should be able to find the vertex. Yeah? Can we move on?
Yeah.
Okay. So my next thing that I want to do, let's just review something, please. Let's just review some basics. Okay? Let's just review. If I tell you m is equal to 3 and the y-intercept is equal to 0, 2, can you find the equation, or can you find, let me spell it out for you. Can you find the linear equation?
Yeah.
Yeah, sure. Okay, what is it?
So like y would be the y equals mx plus b.
Plus
So
b, okay.
the b is the 3.
No,
Does not.
M is a 3.
m is the 3, yeah.
3x. Oh my god.
M is the 3, okay.
X and B would be
Plus 2.
yeah, +2.
Plus 2, yes. So if you're given some information, that's your m, and the b is always the y value, the y-intercept when x is 0, right?
Yeah.
Only when x is 0. Okay? So the idea, so why am I showing this to you? You're probably wondering, like, what's going on here? Why is he showing me this? We learned this, 2 semesters ago, maybe. We should be able to do something similar for quadratics. Okay? Suppose you're given, so example, given the vertex, okay, and the point. Can you find the quadratic? By the way, guys, most of you are home, right?
Yes.
You've been hearing about that word a lot lately, haven't you? Vertex?
Yes. No, sir.
Wow. Have you guys heard about that word for the last like 2 weeks? You've been hearing it almost every day on TV or on the news.
No.
No?
Like
We're
talking
in
about the numbers of the people infected.
Yes, absolutely. The numbers were climbing and climbing and climbing, right? And then they wanted to know what was the vertex, the top. And then they said it wasn't a vertex, it was a plateau. A plateau means it's kind of a flattening off. If it had gone up and just come down, then that would have been the vertex. Do you follow?
Mm-hmm.
So they talk a lot about vertex lately on the news. So if you've been following up what's going on with this whole coronavirus thing, you should have heard of vertex a lot lately. And then they change it after they're realizing the top is flattening out. So we're past that right now, right? We've gone up, it had reached a number, it flattened out, and now we're decreasing, right? Well, at least we think we're decreasing. Let me stop. So far, data have shown it's decreasing. Okay. Okay. So if I give you the vertex, right? So you're find it right. So point. So the vertex given is, let's say, 1 comma minus 2, and the point is, let's say, negative 1, 14. These problems that I'm choosing is on your ebook. So if you happen to go on WebAssign and you look on the ebook in section 2.1, you will see these problems, right? I'm just copying it out for you. Well, if this is the vertex, this is H and this is K, isn't it? Do you agree?
Yeah.
And if this is a point, this is X and this is Y. Do you agree with that?
Yeah.
A point is always X and Y. Now, you know, for any standard form, the formula is f of x equals a parentheses x minus h squared plus k. Okay? Which is also the same as y equal a parentheses x minus h squared plus k. Do you agree?
Mm-hmm.
So if you have h, you have k, you have x, and you have y, can you plug it in these here and figure out what a is? Can you?
Can you repeat again?
You have given to you is h, k, x, and y, right?
Oh.
H, k, x, and y. So let's plug in and see what happened. Instead of f of x is the same as y. So there, I'm going to plug 14. Okay? We don't know what a is, so I'm going to leave it as a. X is given to us. It's minus 1. So minus 1. Minus h is given to us as 1, right? H is 1. So that's 1. Square it plus k is given to us as a negative 2. If we simplify this, we have 14 is equal to a minus 2 squared. This here we can combine, it's a minus 2, which is 14 is equal to a times positive 4 minus 2, which is the way we usually write 14 is equal to 4a minus 2, right? Okay. Can you be quiet, please?
Oh.
Do you follow?
Yeah. So leaving the a by itself.
Right, we're isolating the a. That's exactly what we're doing. So we have 14 is equal to 4a minus 2. We're going to add 2 to both sides.
Mm-hmm.
So we have 16 is equal to 4a. So 16 over 4 is equal to 4a over 4. So 4 is equal to a, right? So now the function, which was f of x is equal to a, because a is not going to always be 1, okay? A is 4. Oops. So we have 4, come on, 4 parentheses x minus, well, let me write out the formula first. A x minus h squared plus k, okay? So f of x now is equal to A is 4. Sorry, guys. X minus, what is H given to you? H was given to you, right? H is 1. H is 1, and K is minus 2. So minus H, we said, is 1 plus a negative 2. But we don't write plus a negative 2, right? We write 4 parentheses X minus 1 squared minus 2. Now, please make sure you notice that when you write in standard form, you leave out the X and the Y. You don't plug that back in, okay? It is very common when students get to this point here. When you get to this point, you get kind of lost what to do. The whole point here is to find A, because A is not going to always be 1. And you did. So after you found A, you just take that A and you plug it in there. Any questions?
No.
Questions?
No.
Yeah. Now, what is the vertex here?
Minus
What is the
1,
vertex?
minus 1, and minus 2.
No,
1 and negative 2.
1 and negative 2. Right? Remember, it's A X minus H plus K, right? So this is already a minus, so the H has to be 1. Since this is a minus, then this obviously, you know, if you write a plus negative 2, then it's a minus 2. Okay, let's keep that. You got to be careful when you're writing it out. Okay. Now, this here is very special. I'm putting that in quotation. Okay. So if I was to draw this parabola, okay, because this is really our goal, right? Our goal is to draw this guy. We want to know what it will look like. At the end of this chapter, you will be able to draw any polynomial. Just like how right now you guys are expert in graphing a linear function, my goal here is to train you, to teach you how to graph polynomials, any polynomial. Now let's look at what we have so far. Let's call this 1, 2, 3. Let's call this minus 1, minus 2, and so forth. Negative 1, negative 2, positive 1, positive 2. You know how to plot this point, don't you? My 1, negative 2 would be somewhere over here. Do you agree with that?
Correct.
This is the point 1 comma minus 2. Now look at the function f of x, guys. Okay, look at this function here. What is the value of a? Positive or negative?
Positive.
Positive. So would this be a concave up parabola or a concave down parabola?
It'll be up. Parabola.
Concave up, concave up.
Concave up.
A is greater than 0, so this is concave up. Now here is something, I mean, this is the way I speak, so no offense to anyone. Anytime it's a concave up, I say the vortex will be a smile. Right? And when it's a concave down, I say the parabola vortex will be a, help me.
Sad.
Well, sad or a frown, yes. That's okay, sad is fine. Now, be careful. Can you tell, maybe you can't tell from here, maybe you cannot tell from here, but I'm sure you could tell from, no, you can't. I didn't give you the general form. Okay. Can you tell what is the y-intercept here? What is the y-intercept here? Can you tell? You know how to find y-intercept, don't you?
Make
Right.
x 0.
If f of x is equal to 4 parentheses x minus 1 squared minus 2, can you find the y-intercept? Someone said it. How do you find y-intercept? Spell it out for me.
Make x equal to 0.
Yes, x equals 0. So you have y is equal to 4 parentheses 0 minus 1 squared minus 2. So this is equal to 4 minus 1 squared minus 2, which is 4 times 1 minus 2, which is 4 minus 2, which is negative 2. So the y-intercept is 0, comma minus 2. Okay? Something is wrong. Something is wrong. Something doesn't make sense. Here's the mistake we made, guys. What is 4 minus 2? 4 minus 2 is positive 2, isn't it? Not minus 2. So the y-intercept is 0, comma 2. Okay? The y-intercept is 0, comma 2. Can't be minus 2. Wouldn't make sense. So this is your y-intercept. So clearly you can see that, hey, I sort of know what the graph looks like, right? I don't quite know. Let me draw a proper graph. I don't quite know the x-intercept, but we could find the x-intercept. Okay. So that's basically what our graph. So that's the idea that we want to get to, right? We want to get to how do we graph these things? Okay. And that's where I'm getting with this. Now, what I wanted to point out to you, why I said that this is a special, this value here is special. Realistically, class, the line that splits the parabola in half, okay? This line is called a line of symmetry. The line of symmetry. And what kind of a line is that? Horizontal, vertical,
Vertical.
diagonal, vertical.
The vertical line?
And the equation of any vertical line is always x equal the
One
h
value.
value of the vertex. Remember, this is h, this is k, isn't it? So what do you think this line of symmetry is? X equal 1. And that is what's special about that 1. That's what's special about it. Questions? Questions?
No.
So let's see if you guys could try one for me. Okay. So given h of x is equal to 4x squared plus 4, let's do minus 4x plus 21. Part A, describe the concavity. Part B, find the y-intercept. Part C, find the vertex. I want you to do this 3 parts right now. These 2 parts, you should be able to close your eyes and tell me. Try those 2, those 3 problems. Yeah. So concavity, first part. Concavity, you want to look at the value of A. So since A is greater than 0, right, meaning it's positive, what can you tell me about concavity? Can you guys hear me?
Concord up.
Yeah, it's positive. It's going up.
Since A is greater than 0, this implies concave up. You agree?
Yep.
Part B, the y-intercept. And you should observe by now, y-intercept for a quadratic is always going to be 0, c. Right? Because how do you find y-intercept? Let x equal 0, isn't it?
Yeah.
If x is 0, guys, this term here will go away, wouldn't it? Because you're going to 0 squared is 0 and you multiply by 4, it's going to go away. This term will also go away. So anytime you have a quadratic, it's always going to be 0, c. So in this problem, A is equal to 4, B is equal to -4, and C is equal to 21. So the y-intercept is 0, 21. These 2 parts here, okay, these 2 parts here, you don't have to do no algebra, nothing. You should be able to look at a parabola and tell. Okay. Questions?
No.
Okay. Now, part C is the part that you have to do some work. The vertex. The vertex is some x comma y. And how do we find x? X is equal to minus b over 2a. And the y will be f of the minus b over 2a. Whatever value you get for that, you plug it in. So we know that b is -4. So we have x is equal to minus b, we said is -4, right? So it's -4 over 2 times a, which is 4. So x is equal to, these 2 negative combine to be a positive, and 2 times 4 is 8. So x happens to be 1/2. Oh, fractions. So the question is, what is f of 1/2 now? Well, you were given the function. Actually, your function was h, right? Your function was called h, so let's write that properly. So h of x was given to you as 4x squared minus 4x plus 21, I think. Is that correct? 4x squared minus 4x plus 21, yes. So the question is, what is h of 1/2? Well, it will be 4 times 1/2 squared minus 4 times 1/2 plus 21. 1/2 square means 1/2 times 1/2. So h of 1/2 will be 4 times 1/4 and minus 4 times 1/2 and then plus 21. If you multiply 4 times 1/4, that becomes 1. -4 times 1/2, that becomes -2 plus 21. This becomes -1 plus 21, which is +20. So this is your h and this is your k. So the vertex is 1/2, 20. How are we doing? So anytime for any polynomial, right? For any polynomial, if the degree is even, anytime you have degree even, this will be true. Okay? And this you can go by what when we looked at the parent function, right? Remember the quadratic parent function was y equals x squared, right? And that graph, when we did this in chapter 1, the graph of this function was concave up. So because the degree here is even, pointing up, okay? Both ends will go in the same direction. Well, what happened? How do you know when it's pointing down? So keep in mind over here, right? The value of a is 1. Okay? So what happens when we have y equal a negative 1x squared? Well, we just looked at that today. When it's a negative, okay? When it's a negative, the graph will point down.
Okay, down.
So still both of them are pointing in the same direction, okay? So the question is, how do we write this, right? Both of these are pointing in the same direction. Now, the way we write it, which you will see a lot in your next math class, left endpoint, the way we write it as x approaches negative infinity, right? Because on the left side of any one of these graphs, what is over here? Isn't this negative infinity?
Yes.
And what will be the right endpoint?
Positive infinity.
X is approaching positive infinity. You don't have to write a positive. I just put it there so you can see it. Okay. So this is sort of the way we're going to write it. We don't say left endpoint and we write, this has the same meaning. This has the same meaning as this. These two things are the same. And which one do we use more? We use this. Likewise, this is the same as this, but we use this one here. Okay. So suppose I ask you a question, describe the endpoint behavior of g of x equals 5x to the 4th plus 2x cubed plus 6x squared plus 2. For the endpoint behavior, right, we said all we care about is these two things here, right? The degree and the leading coefficient. So what you should notice, or what you should tell, what is the degree here? What's the degree?
4.
Speak up.
4.
4,
Even.
yes, degree is 4, even. That's the key, even. What is the leading coefficient?
5.
Right? 5, which means it's positive.
Oh.
That's what we really care about. We don't care about anything else. So anytime it's even, right? Anytime it's even, first of all, we know that this graph, the endpoint will be pointing in the same direction. That's all we know. So it's either going to be going up or it's going to be coming down. Both ends has to be, both of these things have to be in the same direction. How do you know if it's going up or down? This guy tells you. If it's positive, it will be going
Up.
up. So all I can tell is that this graph here will be going up this way and up this way. I don't know what's happening in the middle, guys. At least not now. You will learn that the next time we meet, but right now you don't know that. Okay? So how do we write this out in words? As x approaches negative infinity, right? That's this side here, right? The function was g of x. Where is the y value going? Positive or negative? Remember, g of x mean y value, right? So what is the y value way up above somewhere here? Positive or negative?
Negative.
Is it positive?
Positive. This is negative here. This is positive. So g of x is approaching positive infinity.
When you give out the test, do you want us to write it that way?
Yes.
Okay.
Now you're gonna follow what the homework says on WebAssign, right? Because remember, your exam is on WebAssign. But if you
Yeah,
ever
because the ones we did before where we had to put the U, which if it was two different ones, I don't know why I would get it wrong on the WebAssign. I don't know if I was putting the symbol wrong or what it
make an
was.
appointment, let's talk, and I can go in and look at your WebAssign together with you.
Okay.
Right? You can send me an email and we can go through and we can look at this.
Okay, thank you.
Yeah? You're welcome. So that's the left side, guys. That's this side here. What about this side here now? How do you write that? Well, that's the right side. So automatically you can start as x approaching positive infinity, right? Once we're going the right side, this must be written. Once we're talking about the left side, this has to be written. That's what left means, and this is what right means. Where is g of x going now?
It's going positive.
It's going towards positive infinity. Yes, we said that. Both of these things here will always point in the same direction. So that means this value must match that value. Do you get it? Want to try a different one?
Yes.
Okay.
Yeah.
So describe the endpoint behavior. P of x is equal to minus 3x to the second power plus 4x minus 8. So two things that you want to focus on: the degree. What is the degree? And what is the leading coefficient?
2 minus 3.
Okay, so you have to be able to identify these two things.
2 minus 3.
The degree is what?
2.
2. Very good. Yes. And the leading coefficient?
Minus 3.
Negative 3. Great. So if the degree is 2, right, since this is even, anytime it's even, they're always going to go in the same direction. So they're going to either both go that way or they're going to both come down this way. Okay. Now, since the leading coefficient is negative 3, will they go up or down?
It will be
Down.
going down.
Going down. So it's not this. Okay. So when you draw your graph, at least you cannot draw the graph, but you will have a good idea. You will have a good idea. Sorry, I think it's crooked. All you know right now is that this graph here is going to come down this way, and it's going to come down this way. You don't know what's happening in between here, nor do we care to know. That's all we know. This graph here, the end behavior will be like this. So how do we write that now in words? Let's do left side. As x approaches negative infinity, this function was called p of x, is approaching what? What y value? P of x means y, okay?
Negative infinity.
Negative infinity, yes. Okay, p of x means y. And how do you do the right side now? As x approaches positive infinity, p of x is approaching
Negative
Negative
infinity.
infinity.
negative infinity. Good. Good. Okay. Questions? Now, what happens when they're odd, right? So this here, we looked at polynomials where it's the coefficient is positive or negative, but we look at degree when it's even, right? Even degree. So what happens, what behavior does odd degree have? Well, what's the parent function? You know y is equal to x cubed, right? This is odd, isn't it? Odd. And I've been begging with you guys to make sure you learn those graphs. You have to learn them. Okay? You're going to make your life way difficult later on. So for x cubed, you know x cubed looks like this, don't you?
Yeah.
This will always be the case when it's a positive one. Okay? If you have y is equal to negative x cubed, your graph would now look like this. Okay? So we can say that when the degree is odd, the end goes in different direction. What do we mean by that? This is going positive, this is going negative, isn't it? In a quadratic, in a parabola, they were going in the same direction. Both of these were traveling in the same direction. So that's what I mean by different. Okay? Look, this one is going up, this one is coming down. Okay? So that, and when every time the degree is positive, they both go in the same. Whenever negative, they'll go in different direction. So example, describe the endpoint behavior. Okay. So let's take an example. G of x is equal to 2/3 x to the 5th plus 1/2 x to the 4th plus 5x cubed plus 7. So I know you're seeing fraction, and already some of you start to freeze up. Do we care about the fraction, guys?
No.
No, all we want to know is the degree and the leading coefficient.
Yeah.
So what's the degree here?
5.
5.
5. This is your degree. Okay, degree is 5. What's the leading coefficient?
2/3.
2/3, but we don't even care about 2/3. What we care about it is,
The 2?
no,
Concave up.
it is 2/3. You can't say concave up. This is not quadratic. Cannot say concave up. All we care about is that it's positive,
Oh, okay.
right? We don't care about the 2/3. We only care that it's positive.
Would they ever give you like a whole number in a fraction?
What do you mean? Yeah, you
Like,
could do that. For example, 1 1/3.
but you would still just see if it's positive or negative,
Yeah,
right?
that's all you care
Okay.
about. Positive or negative.
Got it.
We don't care what it is. We just want to know positive or negative. That's all we care about.
Okay.
Okay. So since this here is odd and this is positive, you should have a general idea that this graph is going to look like this. Okay. So we don't know. Okay, let me draw that properly for you. We don't know what's happening in the middle right now. We're going to learn that, but not today. Right now, because this is odd, okay? Because this is odd, I know that this end is going up and this end is coming down. How do I know that? I know that from here and this. So how do we write it out? We don't know what's happening in the middle. I have no idea what's happening there. So on the left side, as x approaches, let me get a smaller tip. As x approaches -infinity, we call this function g of x. Where is the y value going?
Infinity.
Where is it?
Positive infinity.
Where is this going?
Oh no, that one is negative infinity.
-infinity. Right? Anytime you said this means left side, okay? And now let's do the right side. As x approaches positive infinity, where is g of x going?
Same way.
Positive infinity?
Right, this is going towards the positive infinity side. Questions? Questions?
No.
So remember, right? Why are we doing all of this? Okay. A lot of times we're taking a college level class and we're like, I don't need to learn this. I will never use this. What we're really doing here is looking for little tools. I call each one of these things here a tool. Okay. We're looking for little tools to help us so we will have a picture in our next class. We're going to use these little techniques that we have to help us obtain a graph without a graphing calculator. That's the goal. So another tool that we want to use or we want to know about is zeros of the polynomial, which we talk about briefly. Okay, zeros of a polynomial. Now, x equals, let's say I gave you this polynomial, x squared 6 plus 6x plus 12 is equal to 0. Does that work? 4 times 3, 6. Let's make this an 8. And if I ask you to factor this, can you factor it? What are the factors of this quadratic? You guys with me?
Jocelyn.
Jocelyn,
Yeah.
you went to high school, right?
Yes.
In high school, what do you used to call the answer of a problem?
Values.
No.
Solution.
What is it? Speak up. Someone said it.
Solution.
Solution. Good.
Oh.
What else you used to call it back in high school? When you solve a mathematical problem, what do you used to say? That thing is called the what?
Answer.
The answer. Good. Jeez. Right?
Yeah.
So all of these things have the same meaning. Okay?
Yeah.
All of these things have the same meaning. So 0, solution, answer. Okay? And we're going to add another one there. X-intercept. They're all the same thing. The difference is the way you write them, right? For example, if I'm in your class, right, I wouldn't refer to you as Mr. Isaac, right, Isaac? If I'm a student with you sitting in the class, I wouldn't say, hey, Mr. Isaac, or I'd say, hey, Isaac, what's going on today? Or what's up, bro, right? It all depends on the way things are set. So when you write x-intercept, be careful, right? X-intercept, the y value is 0. So it's something comma 0, some value comma 0. Now, you will notice that if you have the factor, can you get the 0? Or can you get the solution? Or can you get the answer? So let's look at this. Weren't these here called factors? Right? So if you have the factor, yes, you can get the 0. And if you have the 0, yes, you can get the factor. Right?
Yes.
Okay. And sometimes we don't see that. So I want to write that out for you. Okay. Sometimes we don't see it. So I'm going to write it out for you. Okay. X equal A is a 0. Is a 0 of the function. So this is one bullet. Bullet number 2. X equal A is a solution of the function. Okay. Bullet number 3. X minus A, right, is a factor of the function. Okay. And bullet number 4, A comma 0 is an x-intercept of the function. Okay. So pay attention, because you guys know this. Is just that when you see math, you get kind of like, I don't know, tense. Is that the right word? When you see math, you get tense. Okay. Why do I say that? If I say given the two factors, okay, x minus 2 and x plus 5, find the polynomial. I am sure of the 21 of you that's hopefully still logged in here, just by writing
Yes.
that, you already said, sorry, 19 of you, you already said, I don't know how to do it. But guess what? You know how to do this. You just got scared because you see some wording there, right?
Yeah.
Let me rephrase this problem for you. Can you do that? Now, I probably got the 19 of you saying, yeah, I can do this again. Am I correct?
Correct.
Because
Yes.
most of you can
What did he
multiply,
say?
Yes, sir.
right? I think you guys can multiply this. But when I say,
Yes.
given the two factors, find the polynomial, you guys got all tens. I don't know what
Yeah,
to
I
do.
didn't know what to do.
Exactly. It is very common, extremely common. Guys, I'm a graduate of BMCC. I took remedial math when I was there.
Got it.
I know exactly the way you feel. Yeah. So if you multiply this, x minus 2 times x plus 5, you guys usually do the FOIL method. X times x becomes x squared. X times this becomes plus 5x. Minus 2 times this becomes minus 2x. Minus 2 times 5 becomes minus 10. And then you get x squared plus 3x minus 10. What do you think this is called? What is that?
Polynomial.
It's a polynomial, yes.
Hmm.
What is the question asking you? Find the polynomial. So all you got to do, y equals x squared plus 3x minus 10. This is your answer. And that's what I was trying to tell you. You see these bullets here? Oops, sorry. Do you see these bullets, these 4 bullets?
Mhm.
If I give you the factor, okay? If I give you the factor, you can get the polynomial. Okay? Now, the same thing can happen, right? Look, if I tell you the solution of, so let's list this as a different example, right? And let's put this as an example here, so at least when you look at your notes, you'll know. The solution of a quadratic is x equals 6 and x equal minus 2. Okay? What is the factors? What are the factors are? What are the factors? Question. Do you know how to do that? Okay? And the question, you should be able to say, yes, I know how to do it. Because if I tell you x is equal to 6, if you minus 6 on both sides, you get x minus 6 is equal to 0, isn't it?
Yes.
And if you have x minus 2, x is equal to minus 2, if you add 2 on both sides, you get x plus 2 is equal to 0. Do you agree?
Yes.
What is this thing here called? And what is this thing here called?
I don't remember. Oh,
Factor?
factors?
Yes, factor.
Oh.
That's a factor. This is a factor,
Wow, I even said in the question, what are the factors? Wow.
right? And if you
Yeah.
have the factor, can you find the polynomial?
Yes.
Yes.
Yes, you can. Yes, you can. And if you multiply this, you're going to get x squared plus 2x minus 6x minus 12, which is
Minus
x
3.
squared minus 4x minus 12. Did I do something wrong?
No.
No. So when
Kind of
you're
like going
given,
backwards.
what's that?
It's like going backwards.
Exactly. That's what it is. It's going backwards. Who spoke?
Louis.
Lois, you know your alphabet?
Yeah.
Say it backwards for me.
Oh, no.
No. Neither can I. Neither can I. I don't know my alphabet backwards. And that's why this becomes a little bit hard. Do you see what we're saying? So it's not that you can't do it, but I guarantee you, Louis, I will bet my bottom, I'm home, so I don't have no money in my pocket. I'll bet you anything that if you write out the alphabet, which you know how to write out, and you take your finger, you can rephrase it backwards for me. I'll bet anybody that. I don't care if, because there's some of you here who was not born here either. I don't care if your first language is not English, you can do that in English. The problem, one of the problem is that when you guys see the questions, right, you get tense up and you already give up. Don't do that. Write out what it's saying. And as you write it, work your way backwards. Working your way backwards, it's not easy to do mentally. But if you write it out, you can do it. I guarantee you can do this. How are we doing? Good?
Yes.
Okay.
We're amazing.
What's that?
I said we're amazing.
You're amazed? Why? Did you say you're amazed or you're amazing?
He said we're amazing.
Oh, well, that's true. Of course. Everyone is amazing.
Thanks, Professor. You're so supportive.
You're very welcome. I'm amazing every day. But you see where I'm going with this, right? If you, and listen, if you just put down your books now, okay, and you wait till next week again when we start this, obviously, you know, you're going to get lost. So you need to practice.